Good evening, all. My name is Madan Karthisen. On behalf of Object Automation System Solutions Private Limited, I welcome you all to the Tech Meet, where we are going to explore the future of technology together. So, our founder and CEO, Mr. Ganesh.
So what is the use of Open Core Foundation? So this foundation was initiated by IBM. It is the open source foundation where anybody can become member and using this power architecture. So what is a power architecture? It is a family of processes. So now people are doing chip design, a lot of things are doing, people are doing. So using this family of processes, people can be a organization individuals can have access to open hardware designs, framework, tools and global community. So what are three impactful things one can do with the open core foundation? So everybody can, organization can become a member, an individual who is interested in chip design or wants to use processes, they can become a member of this IBM Open Core Foundation. So what are the three impactful things they can do? So they can build custom order system with open ISA. ISA is nothing but it's a center of the architecture. You can see instruction set architecture. And also they can leverage the open core power ISA. That is what instruction set architecture means. So using this, we can design custom CPUs, systems on chips, SoCs, and entire hardware platforms tailored for specific workloads. It can be used for artificial intelligence, high performance computing, HPC, or edge computing. So it can also be used for projects like micro So it can be used as a minimal open source software as a base on SoC, like the system on chips, system on power EL platforms. So these are used of open core foundation, and it can be useful for companies and researchers who want stacks. So they can tap into platforms like OpenDMC, Opal, Skyfood for open phone. So, so Object Automation is a primary. As I said, our headquarters is in California. This is our development center in Chennai. Mainly, we got to do three important things. One is this solution development. The other is establishment of tech centers of excellence. So we do this with various universities and colleges. So we are partnered with various global partners, and for that we are working with various companies to provide AI chip design solutions globally. So here, if you can see, we have five. These are the five different verticals. So we started in the year 1996 by doing projects. Then we moved into HPC high performance computing projects from year 1999. Then since 2011 we are concentrating on artificial intelligence, and from 2017 we are doing chip design solution. We have offices in California University and Chennai, India. So mainly we focus on quality technology solutions and client relationships. So among the five verticals, you can see the one which will be most useful for the academic purposes, setting up center of excellence. So what is the center of excellence? Like for example, a lot of universities and colleges are approaching us to have their hardware and latest software to be installed in their premises. So that is called center of excellence. So we as a partner of IBM, we talk with IBM and various partners like Microsoft. We are also partners of Microsoft. So like Microsoft products also the software also we procure and sell to various universities and colleges. We also conduct regularly faculty-led programs. So what do we do with faculty-led programs? So what the industry needs and what is being taught in the colleges, there is some gap between what is taught in the colleges and universities and what the industry needs. So to fulfill this gap, we conduct faculty-led programs for the faculty members of various universities and colleges. And we also conduct cloud and quantum. So quantum computing, knowledge of cloud is essential these days. So we also conduct these courses. So we also conduct training programs for all the students and also for all faculty professionals. So we also place students in US and US and Europe for higher studies. People who do UG, BE, BTech, they want to do postgraduate PG degrees in US, like MS Data Science. So we have tied up with New Jersey Institute of Technology. So one of the premier colleges in New Jersey. So a lot of students have come there. So we help them. So for what people will approach us, students will approach us what they want. Like we will give the necessary information, like what is the GPA they require, so how much money we want to spend, so all those details. So what is the cutoff, so how much they will during the 2 year, how much it will cost, and after completing course, what you can do, how many years you can stay in US, those type of things we give this information not only for US, and also in Europe. I just gave you an example, New Jersey Institute of Technology, because a lot of students are want to New Jersey Institute of Technology for doing MS in data science, because data science is one of the trending courses. And apart from that, we also have four different verticals. So if you can see clearly in the cloud, so most of the things we are working on HPC and AI, where we give large amount of storage space and also large amount of processing capabilities. So with the help of cloud, we are able to achieve these two things. So on-demand scaling workloads, cloud up, all these things. So we also conduct we also do reporting and analytics with respect to high performance computing, AI, and other systems. So these are the three offerings we mainly cater to universities and colleges and also working professionals. So what is the onshore offshore development? So we have a lot of professionals working here, onshore, offshore, catering to AI and chip design solutions. So we also connect research solutions, technology enablement. So Central makes the COE as a talked about earlier. So we provide hardware, software, and we procure the necessary equipments, hardware equipments, and software packages required for universities and colleges. So with respect to this, not only providing hardware and software for universities and colleges, we conduct regularly courses. So for example, in as per the university thing, we have to have an internship program at the end of 8th semester or 7th semester. So regularly, people come here or we go there. We go to the respective engineering colleges. We conduct a 15-day or a 30-day internship program for the final year students. So this is a mandate as per the announcement and regulation. So what they do, people also come here. Now people also will come. So people recently last year, students from a lot of colleges, from engineering colleges in Tiruchendur, they came here. So what they do? So it's a short-term workshops and we regularly conduct in person or on campus. So either we go to the campus and train them, or they themselves will come to our development center in Chennai and come to fulfill this internship requirement. So we also conduct workshops for colleges and universities. So it ranges from 1 to 5 days. So they give us the topic. We bring the necessary people, resource persons from across the world, not only from India, from throughout the globe. We bring resource persons and we conduct the workshop. So recently we have conducted a lot of global AI festival. For example, in August last year, we conducted a global AI festival in Assam, Navapuram campus in Institute of Science and Technology. The year before that, in December, we conducted in Soil Engineering College the global AI festival. So we have conducted a lot of global AI festival and also chip design conference. So these are the two top trending requirements as have been asked by the colleges and universities. Okay, so we regularly conduct various AI course resources and HPC. We have AI resources and HPC resources who do a lot of projects with us. So we also do chip design verification. So we have skilled professionals who focus on chip design and verification for strategic and client initiatives. So these are the two things areas where we do a lot of research. So we can do research on AI-based solutions and also chip design solutions. So it is also for government as well as for industry specific application. So we propose and design the chip design solutions for government and industry applications. So these are our international key collaborators. So you may be knowing these are the famous universities in University of America, the Ohio State University, the University of Oregon, the University of Wisconsin. So these are the very famous universities where we are tied up with for specific purpose. For example, with Ohio State University, we are tied up for HPC and distributed deep learning solutions. For the University of Wisconsin, we are tied up with for Big Data and Python. Whereas with respect to University of Oregon, there is a free 4 years as a software stack. So there is some SQL solution. For that purpose, we are tied up with University of Oregon. So in addition to various universities and colleges, we are tied up with various organizations also, Quantum Ventura, the Institute, the Nextcase Solution. These are the companies who provide our software services. So HPC is a very big thing, high performance computing. So it requires a lot of software. So STL Solutions is one such company where it uses parallel processing. HPC is a parallel processing where you use most of the process parallelly. So one of our important thing is we are tied up with a lot of we are tied up we are signed memorandum of understanding with various universities and colleges. So you may be seeing, you must be knowing most of the universities and colleges. So not only in Tamil Nadu, we have tied up with various states of India. So for example, if you can see here, New York College of Engineering, it is in Bangalore. Then we have also JNTU, Jawaharlal Nehru Technological University, it's in Anantapur, Telangana, colleges and universities. So whatever the needs of industry, we are going and teaching the students. So recently also, from Monday, we are going to one of the institutes in one of the engineering colleges in Chennai. We are going to conduct this IBM career education program where it will be a co-guided. So certification will be issued by IBM and the materials, everything is provided by IBM. We, on behalf of IBM, we conduct the courses. We go in person and teach them, like welcome to data science, Python, all those things. So this adds value to the resume. So what are the things we do? We do artificial intelligence, machine learning, cyber security, cloud computing, blockchain. So these are the popular trending courses. So what are the key features? It's hands-on learning. So not only theoretical, we make the students do practically hands-on in the lab. So IBM Soft Lab is provided by IBM. It's a co-brand certification. So you have the IBM brand, you have the certification. So it adds value to the students when they go for when they search for jobs. So yeah, so we are teamed up with various universities, startups, ISVs, and industries. So what is the main purpose of this? To have an impact on artificial intelligence solutions for real world opportunities. So these are our these are the technology we use, and also some of them are partners we are partnered with. For example, the AI lab. So we just IBM and other corporate sponsors. So the AI lab it has been sponsored by IBM and other partners, and some of our open source technologies. It is mainly used for to accelerate the students' career, tech career. So you can see Red Hat is a variant of Linux. So you can see about 10 Ubuntu, but is also a variant of Linux operating system. So IBM Watson, using IBM Watson, what you can do all artificial data science, all related projects. So OpenBower, I just gave you a brief introduction at the beginning. So OpenBower Foundation is an initiative by IBM where you have ISR, Institute you have an institute architecture. So where any people who is interested in foundation can make use of it. So we have the GPUs. So this Power AI is another platform by which one can make deep learning, machine learning, and AI more accessible and more performant. So deep learning it requires a lot of hardware resources. So we need a lot of power. So with the help of Power AI enterprise platform, we can do all machine deep accessible to people, and it has more compute resources. It runs on the AC 922. So these are the special courses Object Automation provides. So we can see machine learning in Python, enterprise AI, applied AI, quantum computing, cyber security. These are some of the top trending courses we provide. So these are the softwares used IBM DB2. I talked about IBM Watson, where we use IBM DB2. So it's a database. So it's used for machine learning. So I was talking about E4S. This is a software. This is mainly used for high performance computing. So people who are in the high performance computing may be knowing about this extreme E4S, or also known as extreme scale scientific software stack. So it helps us to do parallel processing. So what happens is sometimes we want to do processing the parallelly. So it saves time. It also makes your time project will be able to finish the project in few seconds or minutes. Yeah. So this XScale and AI and XScale HPC, these are the software packages. XScale AI is used for artificial intelligence. It is a high performance solution. It's for distributed training for complex AI problems. And XScale HPC is for complex HPC problems. So these are the two things from XScale. And XScale is tied up with Ohio State University. You can see XScale AI and XScale HPC. These are the two different solutions. So at the very beginning, I mentioned about Object Automation. We just tied up with OpenBower Foundation, and also we are tied up with University of California, San Diego. So these are the courses we provide. So we have trainers from around the world. So they provide training to the students who are learning various courses, like for example, machine learning, data science. So we are providing for the students. We are providing this training to the students. So University of California, San Diego campus. So these are the courses you can see. This is one of the just example. We conduct a lot of courses for University of California, San Diego. This data science is one of the data science with practical applications. So for example, in India, so most of them will be theoretically, will be taught with theoretically. So where in US and other countries, they expect us to teach hands-on. So most of them there will be less coverage for this, there will be less weightage for theoretical thing. Most of them will be hands-on applications. So these are things related to Silicon. So our CEO and the founder, and also the vice president for Open Door Foundations, Mr. Ganesan Narasamy. So you can reach him through his phone number. And if anything you want to, if you want any information about Optical Automation, you can also mail lecture@opticalautomation.com. So, so you have any questions? This is just a brief explanation. This is just a brief profile about Optical Automation. Mainly we cater to three things: research and academia. So I also welcome all the people. I have students from SRM Ramapuram, faculty members from Anna Institute. Thanks for coming to the Open Tech Meet. Okay. So now I invite Mr. Sudhir Balan, who is a student of SRM Kataguda. So he'll be giving a talk on chip design.
So good afternoon everyone. I am Sudhir Balan, studying SRM University, BTech Nanotechnology. Today we are going to see about the micro and nano fabrication of silicon. So, demand for silicon. If you take a silicon, it is taken from the sand, and then the raw material is from the sand, and then converted into the silicon, solid silicon structure, and that's it, to be transferred into a chip. So annual growth will be for the computer. We have to see that list of data here. Design market share by recognition of the company HQ. Like in 2000, you can see the list of countries. In 2000, 50%, 48%. In current market, the leading person is US and Japan. Japan and China are making silicon more. Why? Because they are in more amount of production in silicon technology, and the Silicon Valley, which is in the US, have developing more and more amount of chips, like silicon raw material distributions, and they distribute to the other countries to get new revolutionized chips. So 2021 global market share, like in 2021 US market share is 46%, and the other countries. Next, the victorious cycle of innovations. Now we are going to see about the fabrication process. Like, these are the fabrication process for silicon to fabrication. Once we get with the file, like design file, and then design file is converted to a GDS2 file format, and then the GDS2 format is given to the manufacturing unit. Those people will see the in-group growth, slicing, edging, grinding, lapping, etching, polishing, and cleaning. These are the steps to be followed in the fabrication process. I will teach you one by one with the raw material, those kind, not a whole processing unit. It's simple transistor and capacitor. We have taken a raw material such as silicon, grouped into a lot of 25 wafers. It goes to oxidation, deposition, and diffusion. Oxidation is nothing but the silicon is exposed to air or oxygen, and then the chemical reaction happens. Then oxidation appears on the surface of the silicon. Once it's done, then we deposit the another layer of photoresist. Photoresist is nothing but uh, when we infuse or when we give light, the photoresist will either it will penetrate or will reflect. Like there are two types of photoresist. One is positive photoresist and is negative photoresist. Based on the application, we are using either one positive or negative. Next one is diffusion. Diffusion we are using is to make the silicon either N well or a P well or N type well silicon, C type, P type silicon. This is photolithographic process which involves UV light. UV light gives the photoresist to penetrate into the silicon, and the structures like the CMOS diagram, the physical diagram, digital diagram is converted into the surface of the silicon there, and proceeding with etching. Etching is nothing but the layer of the photoresist is taken out and which is etched onto the surface of the silicon. We further process and we finally get a final wafer. So like, we have seen the development of cycle of IC from application. This is the design, fabrication, and circuit integration. So single crystalline silicon wafer fabrication for MOS transistor application. MOS is nothing but metal oxide semiconductor. There are three grades of silicon we used here. One is the raw material, which is called as a metallurgy grade silicon. There are many possible defects made in the three phases. First is the raw material purified, and then purified silicon is called metallurgical grade silicon. And the second phase, MSG, metal grade, metallurgical grade silicon, is further purified and highly purified semi-crystalline silicon, like polysilicon. Then is applied the silicon crystal which comes out after the second phase is called electronic grade silicon, which is used everywhere in the electronics sector. The third phase, highly purified ESG grade silicon. Why we are using the highly purified ESG grade silicon? Because to get maximum output and the performance from the silicon wafer. It's transformed into a crystalline silicon. Once the crystalline silicon is applied, it is cut like this slide and into thin pieces. Thin pieces such as in a micrometer or in a millimeter size. This sliced silicon is called silicon wafer. Usually the silicon wafer is the size of like in the diameter of 30 centimeter. These sliced silicon wafers are called IC fabrications. Now we are going to see about the two techniques. Which one is the Pokransky method, and another one is a float zone technique. First, we see what is a Pokransky technique. You have seen the diagram, which is clearly shows this is the RF coil. RF coil is radio frequency. We given a radio frequency in the coils. These are copper coils, and this is a machine output diagram. It rotates in its axis. That's a shaft, and we cut the silicon grade highly purified ESG silicon into thin pieces and put it into the board. This is a silicon melt, which is in the heating in degree of 1500 degrees Celsius. Like once it's gone to 1500 degrees Celsius, it's in a melted state. So then we are introducing a seed structure. Seed is nothing but a pure crystalline silicon, which is in a 111 crystalline orientation. That's the orientation of the lattice fission. And then silicon crystal is rotated in both the sides. This one in clockwise rotation and in upwards anti-clockwise rotation. At one time, we are pulling out the system from this. So we get a silicon grade. See, silicon crucible is which is melted at the 1500 degrees Celsius. So this is a industrial level setup using in the semiconductor industries. The next one is a float zone technique. Like same we have seen in the Kruskalski method, float zone technique is different from that. Why? Because here we are introducing the polycrystalline ingot. Ingot is nothing but it's like another material from external source, so that we get a silicon, industrial grade silicons. So we are introducing RF coils radio frequency heating coils align the sides of a rotating unit, one in clockwise direction, another one in anti-clockwise direction. We introduce polysilicon rod in the upward direction and in crystalline silicon gold in the downward directions. After the process, once we take it out, like pulling from the both the sides, we get a region like this. This region, once we get and ready to coolify, we get a crystalline diameter wafers. Like these are the wafers of this crystal orientation 100 and aligned in 111. Now we are seeing in the uh, plot of CPU microsensor transistor count from 1971 to 2018. So you can see like in transistor count like 1000 in 1970. It's a early stage in the semiconductor industry. For today we have seen like it's around 5 million or 50 billion transistors in a single chip. Like the chip is in the size of centimeter size. Even your phone has a chip that controls the performance. So the number of transistor and integrated circuit chips from the 1971 to 2018 data. Fabrication of semiconductor devices. One is the front end and the back end. We have discussed in the front end so far. Now we are going to the back end. Front end consists of wafer fabrication, wafer probing, and the back end consists of assembly and the final test. So this is the back end process. First food process is wafer probing. Not a human going to involve it. Only machineries and handle the wafer, sliced wafers. So this step takes between wafer fabrication and assembly. Like wafer fabrication and assembly. It verifies the functionality of the device performance, the electrical test by means of special micro probes. These probes are in so that test every transistors in the inside the silicon. Wafer probing is composed of two different tests. One is process parametric, one is full wafer probing test. Process parametric test is this test is performed on the some test samples and check the wafer process fabrication process itself. Like, we are creating a silicon wafer. Then once we introduce into the photolithography process, we created a structure in a silicon wafer on the surface, and then we are checking whether it's about the functionality and performance of the silicon after getting into the finalized product. So this is intermediate procedure, and full wafer probing test is a final test. Like after all the materials are finished, we have output like single silicon chip. So full wafer probing test is like this test verifies functionality of the finished product and is performed on all the dies. Based on the performance of the single chip or die, it is categorized as the grades like A grade, O grade, those kind. The bad die are automatically marked with black dot so that they can be separated from good die after the wafer is cut. So these are in a single wafer, not a cut. After this parametric tests, we are going to cut into the pieces and then further goes. A record of what we went wrong with the non-working die is closely examined by a failure analysis engineer to determine whether the problem occurred so that it may be connected. The percentage of good die on the individual wafer is called yield. The percentage of yield is larger amount of yield is we expect large amount of yield to get performance. So this one is the wafer die silicon wafer in a millimeter shape. It is cut into pieces using a diamond shaft. The back-end semiconductor manufacturing process, the complete wafer is sliced into chips. Automated method include mechanical sawing or laser cutting. Mechanical sawing includes the saw, which is composed of diamonds implanted on the outer of the saw. Using laser, we can also use it to transfer the chip to the die bonding process. Die bonding process, nothing but here we only have a chip which is not which is exposing to the air now. We don't want the chip to expose to air so that there will be no contamination in the chip, so that we get a high performance and we get a more amount of yield from this. So this is the assembly process. Like First we dice the silicon wafer, we dice, then the silicon is chipped into the mount. This is a chip mount. We placing the diced silicon wafer chip into the mountain, and then we get a wire bonding. This wire bonding we are running with a gold plate wires. These wire bonding plated wires are in a region of micrometer size. These are not done by humans. These are done by using machineries, robotic arm to get a implant on this. And with wire bonding, we proceed with the molding so that the it will not expose to air. Trimming and forming. Trimming and forming means the wire is connected to the chip, but there is some excess in the length of the wire, so that we connect the resistors. So far we have learned about the manufacturing process of a silicon wafer. So that's all for.
Thanks to the caller for a talk on growth in silicon systems, where you explain in detail clearly how a silicon is manufactured from silicon to chip. So we are waiting for the chief guest. They are on the way. Please bear with us. Hello, sir. Yeah. Okay. Well, long time. Long time. So, yeah, you can sit down. Get the chair for. Yeah.
So last week is Power 11. Well, more obviously, I can do which is mostly of stuff. Power is
Yeah, I understand. Yeah, we can do that. We can do that.
I can do
I,
more.
thanks for coming here. Good.
I can do more for my.
That's why you want to play. And also, I brought one person from IIT Madras along with me. Uh, he's Mr. Koteswaran, and he's working on Shakti processing. So the other open source, Mega thing, what is happening under the IIT. Okay, so now as part of this tech meet.
Excuse me.
No?
Like this.
Okay.
So this one.
That I have to hear.
Yeah.
You are really yes to me.
Yes, yes.
Like this. Okay. So
I can't use this.
You can.
okay, in terms of timing, I just want to have a quick introduction about Peter Ofsey. Uh, he, he has come here with a lot of experience, nearly 29 years. He worked with IBM from the Sony PlayStation and also the supercomputers, and now with a lot of IBM, the power servers and all this stuff. Certainly, you know about IBM Power very well. We'll have a private discussion with him too. He's from HCL.
Yeah.
That's what I'm saying. Yeah. So in terms of timing, I want him to do the presentation now. Peter, you can start now.
Alright.
And
This may take a little while because it's big.
what is the reward?
He needs the presentation. He says.
YouTube. Yeah, there's a streaming also.
Essentially, it's a conflict.
I cannot put USB on my system. IBM doesn't.
So now, okay, this one you can just talk about it.
You don't need to, if it is
No, it's not confidential, it's not a problem, it's just big.
Oh, yeah, okay. Yeah, I think
Is there any limits in fees and
we can just talk.
Okay,
The audio is there.
so,
This one,
yeah, but it's oh, it's because you're standing in front.
oh,
of it.
yeah, no, no. I'm not.
I'll send the, I'll send, I'll send the presentations after the thing, and then you can distribute.
I can distribute. Sure.
All right.
You have to keep the thing closer.
Okay.
You
Good.
talk.
All right. So what I'll do is I'll spend about 30 minutes on kind of what IBM is up to with the power processors that we build, and then I'll talk a little bit about microwatt as well. So, I know some people here in the audience are interested in that. But first, by way of introduction of myself, this is a kind of a picture I use. So like Vanessa said, I joined IBM 29 years ago. First thing I worked on was a 1 gigahertz power architecture processor. It was the first 1 gigahertz processor that anybody built. So that was the first one. It was a 64-bit power integer processor. And then, in part because of the attention that caught, Sony came to us, to IBM, and asked us to help them build the PlayStation 3. So that's how I became, one of the architects of the PlayStation 3 processor. With some heterogeneous designs for that with the PSPs and the power processor. And then that led to Roadrunner supercomputer, which was the world's first 1 petawatt supercomputer, which was. And then I wanted, after Virtual Cell, I was interested in this notion of sharing memory between conventional processors and accelerator type devices. So, but now I had to do it on a research budget rather than on a development budget. So I started playing around with FPGAs and using the Power 7 processor, I created a prototype of something that became the happy interface, and then later that was on Power 8, and then the open happy interface on Power 9. And basically that whole stream of development is now flowed into the CXL standard, which is kind of the future of PCI Express. And the idea here is indeed to take the kind of sharing that we did between regular CPU cores and accelerators that we did within the chip with cell and take it to a system level. Along the way, I also developed a compressor, the GZIP compressor on FPGAs. It didn't really have much to do with this memory sharing thing, but it was one of the applications we did. And that one made its way into various IBM products, including the power processors and the C processors and storage flash products also actually have that compressor. And then I started working on big data systems. So this whole compression decompression thing is actually also kind of in the context of big data systems. I had a professorship at Delft, which is on the big data side. And then, my more recent work has been on sort of more mainstream power systems. So, this is I might have put the and so there what we are doing is so we used to do development of power processors and systems in Austin, Texas, as well as many other locations around the world, including in Bangalore. Actually, for future generations of power systems and processors, including the software stack and everything, the development is actually going to be centered and led out of Bangalore. So, my job this year and maybe next year is actually to work with the team in Bangalore to help get them ready to do the future processors or AI processors. And the bulk of the development for the power processors, including the leadership, I should emphasize. Actually, this is not a question of having a big team here, but having leaders in the US. The team will be then here out of I mean, hired the chief architect, Jayesh Kaur from Intel. They're very happy with. So they're a strong leader for the team. And this is just an example of one of the many job postings that you can find out there. Of course, our systems, even though the systems themselves are proprietary, IBM decided to take the ISA and basically manage Azure several years ago. The ISA is managed as a fully open architecture. It's managed under the Linux Foundation, right? So get the Open Power Foundation. So every time, even if IBM wants to make a change to the ISA, we have to take it to the workgroup underneath the Power Foundation to get our RFC proposals accepted into the architecture. We publish the open version. So even IBM actually, that we ship them the latest level of the power. So there's not some back level version of the architecture that's open and then all for IBM that is perfect. No, the one that IBM uses is the open. So for the systems that IBM builds, just to give you a little bit of context, why the systems that we build with the way they do. Main users of our systems are enterprise customers. Quite often things like banks or companies that have to manage distribution or supply chains or things like that. So the database tends to be very central to these customers. If you're doing a financial transaction anywhere in the world, actually, there's a very high probability that that financial transaction actually gets tracked, that the database runs on an IBM system, either an IBM mainframe or an IBM power system. Here in India, we care tremendously about stability, reliability, scalability, because these are very large databases. You'll see that our systems grow up to 64 terabyte image in a single system. Security, of course, is another one to pay a lot of attention to that.
We do virtualization, across systems or moving it off and on systems. That kind of thing. So that gives us also a lot of flexibility. So right now, we're on Power 10. I'm not going to spend too much time here on this slide. And this is what one of these systems looks like, right? When it sits in a rack, it's sort of it's like this big. And as I mentioned, they can go up to 64 terabytes. Now 1920 threads, so our things go up to 240 processors, but each of our processors has eight threads, 8 hardware threads, each of our CPU cores. 3 different types of operating system. We support Linux operating systems, actually not only Red Hat, also SUSE, AIX, IBM I, those are the three main operating systems. And here's, a little bit more detail. There's a lot to talk about how this is engineered. I'll mention a couple things at the end. On this picture, one thing that I'll mention is, usually when you have a processor, all of the connections from the processor, from the module, they go into the board and then they go to other things. IBM has actually engineered our modules to have, connections right on the module itself. So some of our high bandwidth connections actually come, out of the top of the module rather than go through the board and so on. So this is one of the things that allows us, to create a lot of bandwidth and also have low latency in our systems. Because if you're trying to build a system that scales well, you pay an enormous amount of attention to having low latency connections. And here, this is a different system. This is a 4-socket. We call this and so the one that I showed, I think we call an E1080. It's our big system. This is our mid-range system. This is a 4-socket system. If you look at the picture, you see the 4 sockets. You see, these things in kind of blue. Those are voltage regulator modules. And then you see the memory. It's sitting under these kind of, somewhat silvery-looking cages. So IBM builds our own memory modules where I'll have pictures of that in a little bit. So, when you think about a power chip, it's actually, you can think about it as a giant switch. So we have 16, and then we get the high bandwidth because of the high bandwidth and high reliability because of the serial interfaces that we built. So this is how we get to that combination of reliability, bandwidth, and capacity that people value in our systems. If you go down to a 4-bit floating point format on let's say an SMT8 core, you have you have 1,000 operations per cycle this way, right? I described how with 32-bit floating point you get 16 operations. We have an accelerator that IBM Research has developed for the Power Platform as well, right? So we've already been using that accelerator called AIU in some of our mainframe products. So in the prior generation mainframe processor, we included a few of these they call the rapid cores, AI cores, along with the regular cores, inside the processor, creating again, sort of a somewhat heterogeneous architecture. And this is based on work that has now become fairly mainstream, but IBM Research actually was one of the first places to show that you can usually do AI computation, all the way down to those very low precisions, like inferencing with 2 bits. And there was even work, with spiking neural networks where you could argue it's a 1-bit kind of thing. Right? So those very low precision operations, of which you can build a lot of them in a chip, are quite useful, right? And this AI accelerator that IBM Research developed, packs even more of those operations in the same amount of silicon than we do with the power processor, which sort of stands to reason, right? Because in the power processor case, the thing is optimized to do a whole bunch of different things. And yes, we have a matrix unit sort of as one of the things that our cores can do. But this here, the whole chip, is optimized to go after AI and those, lower precision operations in particular. So that chip called the AIU will end up on a PCI Express card, and IBM has advertised the intent to enable those PCI cards to get, my expectation is something in the order of an order of magnitude more AI performance. If you add a bunch of these FPGA cards to a Power 11 system. And then, I don't know how many sort of electrical engineering kind people are here. I have one example of something that we do on Power 10, and then I'll talk about something that we're doing on Power 11. This is really more at the circuit level. So, I mentioned stability as one of the values that our customers care about. So we want to be, do things like voltage frequency management, but we want to do it in a very deterministic way. So basically what we do is we measure the effective capacitance that an application uses. So basically the switching factor that a particular application drives. And then based on that switching factor, we will set our voltage and frequency somewhere, basically to save power, which is similar to what other people do, but they tend to do it in a less controlled way. So now then it becomes a little bit unpredictable, what frequency you're actually going to run at. So this remains, predictable because we measure that C effective ratio, and that's a fixed thing. But we get the same kind of effect. And then there is a particular technique called undervolting, and I'll try to explain quickly what that is. So we built a number of sensors into every processor. Here it's shown for a pair of power cores. And we have things like temperature sensors, but also a digital droop sensor. So we can see if the voltage is dropping. And then what we do in response to this is actually we have a control loop. And actually we have two control loops. One of them is very fast. And that if you see the voltage dropping too fast, so that you think the voltage might become too low to where the processor would start to fail, you stop issuing instructions at the same rate that you otherwise would. So you basically start to slow the logic down. And this is a loop that we do in hardware. There's no system controller or anything involved. So this, because you have to operate your processor with a voltage margin, so that if you have this kind of a noise that happens when, for example, you go from an application that does no multiply adds to an application that does a multiply add every cycle, your current is going to go, it's like a step function up. And when you do that, your voltage is going to go, really get a dip. And if you have to have your voltage high enough that you can always withstand that kind of a dip, that's quite expensive, that you have to keep quite a big voltage margins for this. So what we do here is, because we have this, very fast mechanism where we can protect ourselves against how much the voltage can dip, we can put the voltage much closer to the, we can operate it at a lower voltage and still be protected, that we're not going to hit that point where the processor is going to start to fail. And that's what you see here, instructions that depend on, like low compare add branch, lots of branching, a lot of depending, and it's very difficult to get the processors to be very busy if you're doing that. All the 8 threads are very helpful in that kind of a scenario, but still the switching factor is not very high. So in that kind of a scenario, you really can get either a lot more frequency, or you can save a lot of power by having pulsator. If you're in a fully loaded scenario where you're doing like multiply adds all the time, you still save some, but the biggest amount that you save is when actually the activity factor is low. So and this is just more detail there. And then in Power 11, you'll see that we'll start using something That is the ISC, the integrated stack capacitor. So another way that you can protect yourself, against these current spikes is by building more capacitance into your processor. And this is a technique that Samsung, who is our current technology provider, has developed to get more capacitance right in the silicon. They used to do this with sort of DRAM type technology, deep trench capacitors. This is a somewhat different way of doing it, but it actually achieves a capacitance density that is similar to what you would have with these deep trenches. So this will, we haven't advertised yet what the frequencies will be on that next processor, but you can expect them, to be a bit higher than they were to build generations or several generations of microprocessor after some time. Motorola, then Freescale, now Nexperia, I guess, is sorry, Motorola. No, I think still, yeah. They built a class of embedded processor, power processor architecture chips, and some on this system. So it's a very small processor, but it has enough capability in there to actually be run Linux. And they added some of the latest innovations in the architecture. For example, there's something called prefix instructions, where in Power 10, with a certain opcode, it tells you that there's another 32 bits that is going to be considered part of the same opcode. And we use that to, when you have branches that need to go to an address that's pretty far away, we use this kind of prefix opcode, or for certain loads and stores, for example, too. So it's included. And it's it's really very, very small. It's some tens of thousands of lookup tables, which is the basic element in an FPGA. Kind of the equivalent of a NAND gate if you're doing synthesis, but of course a lookup table is a slightly more complex building block. But that's your unit in FPGA. And like I said, it is Power ISA compliant. And I actually, well, I'll show that in a second. So this is the pipeline. It's a little a couple more pipe stages than I think you would find in your typically computer architecture class, like Hennessy Patterson type MIPS D processor. I think that's a few stages less, but it's still not very deep, right? It's an ICAche access stage, couple of decode stages. Execute here. It says execute 1, 2, but if you're just doing simple fixed point operations, then it's really just one cycle. And then you write back the results and you can forward them. So it's like I think it's basically like a six stage. And then it might be there might be an open standard around ONI. I don't think there's not. We actually worked with for the DDR4 generation. We worked with a third-party company to design the memory buffer chip that sits on these things. So that was not an that was a, ultimately that was IP of that company, not an IBM proprietary design. Yes. Yeah. Good. All right.
You want to add this Bluetooth on the right?
So like the introduction and the overview of DeepSeek platform and rack concept, so that I will give you a basic knowledge like how it will be working in the rack slide, and introduction to Streamlit and Olama. So it is like a local software that is going to use for our current project. And next, the challenges and consideration while implementing this project, which is we will have to face it while implementing the project. And right. So for the introduction, so we just having the roles in modern tech, like explains how Gen AI models like drive into innovative applications like Cochrane Industries. So these models actually didn't analyze data, so they just generate new outputs and create like the human creativity models also. So we see that embedded everywhere. So from, for example, we can take it as ChatGPT. So we know everywhere, like we just giving a prompt for that, and we're just getting a proper response. And the ChatGPT involves in the prompt designing work also. So you can, for example, we can take it as when you just type a sentence or an email format, just we can assume that some random passage into it. If you just give the prompt as give me the email format or give me this passage of like 2 lines or 2 paragraph, then depends on the prompt that which you are giving for that, then depends on that it will be generated the output. So which all be considered like, for the example, we just taking the chat GPT as of now. And the content, like you may just know the Studio Ghibli feature, so which has been trending over the Instagram also. So in this particularly, like when you just upload it and you just convert the image into the Studio Ghibli, like it has been starting recognizing your text into it, and it is starting recognize your Studio Ghibli word into it, and it is generating a perfect like animated image for you. So that kind of work also been included in the Gen AI. So this all composed of like which involves in the Gen AI, so which includes the images and text and everything also. And industry impact. Hello. Yeah. Industry impact like demonstrates the transformative effects in fields like healthcare, finance, creative arts. So in this, like we can like a health bot can be the best example for it. So nowadays websites are available. So in that website you can check it. Like there are different types of models which is already pre-trained and it is been developing also. So if you just check, then it will be like the files will be maximizing in that. You can actually, if you're just in the field, if you're in a Gen AI field, that you can actually saw a difference in it. So that which includes in the current sentence like Gen AI models, and that sentence which refers to that particular passage in it, and like deploying scenarios like introduce the real world use case and potential for practical application. Like this is a DeepSeek platform, so it includes like core functionalities and key features and integration ready, performance optimization and real world application. So first of all, DeepSeek, which is way. So in this like in the project, we have deployed the DeepSeek models also, so that as it is more trending and it is more efficient to implement that. So we are using the DeepSeek model in our project to get a better response and with maximum accuracy. So this is what this slide is depicts there. Like list out capabilities such as scalability, real-time data processing, and seamless integration. Like we just used this for integration purposes. Like when you just run the things in the back end and you just want to integration and all the things will be happening around it. And performance optimization, like in which the integration ready also completed, and resource management and high performance computing support. As you know, like there will be like started a fight between the chat gpt and the DeepSeek, like which is more efficient when it's compared to like the chat gpt which announces many other plans like premium plans and anything. But meanwhile the DeepSeek is providing many things free plans also, and providing many features like than the chat gpt. But quite like to be honest, like chat gpt is like giving the better response when compared to DeepSeek. So like these are the features of DeepSeek platform that you can use for, and this involves in that particular slide. Yeah, this is RAG concept. So retrieval, it defines like retrieval augmented generation. So that okay, you have already imported the Streamlit for it. Okay, this is an front end interface so that I can connect you it and I can like produce a result for it. So that is what we are calling the Streamlight platform is for. So it is like a front end interface that you can check how efficient and how how accurate your model is properly trained or not. So it is like an interface. So yeah. So next week refers to the Olamma. So it is nothing but it is like a local software installation. So in this, it will be like listing out like provide an introduction to Olama to the GenAI application, which is introduced like for the GenAI application only, and distinct features like outlines that unique functionalities that differentiate Olama from similar websites, and which explains the Olama can be integrated with DeepSeek, and all these points which is refers to. So we can take it an example. So when I just started a project which like it will be answering the information depends on the PDF that we're going to upload. Multiple organizations and even our organization trying to implement the chatbot with using this Olama model. So we are using the model called GPT, and from the Olama we're just using Gemma 3 and Excel model. So because as we have searched for many information, so these two models are more efficient when it's compared to. So I think that you can also use it for the practice. So we just use this, but the thing which is negative for this Olama means like it is a local hosting, so it needs a public URL for it to deploy for the any public interface of chatbot. So if you want to like upload your chatbot in your website, so some backend work has to be running continuously, right? So that when the user comments any prompt in the website, it goes to that particular server or what the server it has been running in the backend. It has to be running. So, but though it is a local system, that we have to run it in our any server like Azure or any local server also we can run it, and we just introduce some other technique called in our chatbot we just use the N0 one thing for the deployment of for getting the public URL. So in this like some challenges that you can face for Olama. So though it is local, like not an issue that you can create it a public URL for it so that you can generate a better response. So that is all which comes in the Olama and yeah, this is a RAG flowchart architecture as I already stated you. Like it is a vector database, so which is used for the chatbot. So which recognize the prompt query and prompt and enhance the text, and which goes to the relevant info. So the example of RAG is like if you just enter any random prompt like who is some any kind of member that you can select for, it will be start like searching for the relevant info from your database. So that is the first thing that the RAG will do. So that is being represented there in the text box flowchart architecture there. About common issues such as scalability, performance, and bottlenecks and resource constraints. So scalability, like which is and some things like other than Azure, which is like AWS platform, which is having the manual scaling will be happening there. So this all hurdles will be comes in account. Like scalability is also one of the hurdles, though it is being mentioned there, and security and privacy. So though for every other things and every related things, there will be a security and privacy will be there. So some engineering work will be done in the backend. So that has been depicted there, like data security, user privacy, and ethical AI usage and integration complexity. Yeah, we are be facing many issues like in the while in the during the integration, while we just produce some public URL from it and we just importing in the front end. We are just facing many other issues like compatibility challenges and multiple tools. Some tools will be not supporting to our front end and some have to be manually installed. So these kind of challenges and that we are just facing in the real time. So that has been referring to that, and continuous monitoring like emphasizes the need for ongoing evaluation and iterative improvements. So some other job schedulers will be assigning to that for the continuous monitoring of the work. So will be done in the backend, and future adaptability like for necessity for flexible and future proof deployment strategies. So this will be depicting about the challenges and consideration while implementing your kind of chatbot for your company's website or whatever the field that you are choose for. So this is the just about what is the backend works and what are the technologies being used for creating the chatbots. So that's what I've just explained to you. So that's it. So like with using this using this kind of concept that I've deployed some created chatbots which for the company. that as we have done, I mean, done only in the backend work, so it will be generating and listing out the proper response in the backend, like in the terminal itself. But though it is like done in the recent days, we have like
Hello. Hello. Yeah, good evening everyone. Today I'm going to show you that just I'm going to explain you that what we are offering, that what we are providing. So we are mainly into this chip design where we partner with this IBM and OpenPower Foundation where they provide some open source tool to develop this chip design. As the Petrovskis has said, the IBM has developed an software processor called Microwatt, which is an open source one that is available. You can able to work on this processor that where you can see. So it is the thing which is written in VSTL. It is basically built on the Power IS into that how a processor has been made like that for getting into a deep understanding. You can work with this called the microwatt, where just you will just clone this microwatt and you have to install some tools. After that, you will generate a bit file. So after you generate a bit file, you will flash it into a board. So the microwatt is available to test in this FPGA board thing. So this is for FPGA board that is field gate programmable array where we will flash your the software processor that the IBM has developed. So once you flash your microwatt processor into this FPGA board, so it will act as a processor kind of thing where for this future add-on thing, we'll also able to boot Linux into this micro processor where we will download the Linux kernel image and we will flash again into this FPGA board. Then this FPGA board will work as a processor with a booted Linux into it. Uh, so by working on this microwatt, you can able to see the GitHub link available. So when you go through that, you will able to get a small understanding of how a processor has been made, how you can work on that. So that is the one thing. Then it is basically front end part where we will write your design RTL code into RTL code and you will test it by writing your test bench, and after that you will generate your bit file and you will flash it, that like programming your board like kind of a thing. So that is front end part where uh, you can try with the microwatt open source tool, and also a tool called Verdo, where you will use to write the RTL code there. Then you will add some source file, that is the RTL code source file, and the required constraint file and the configuration file. The configuration file contains this board information. When you add this constraint file according to this FPGA board, the thing into this Vado tool, you can able to test the required program that you had been program the board like that kind of thing using you can able to see some switches like that. You can connect with the board and you can start to work on this after you do program. So for that, we can use the tool called Verdo. It is an also a open source tool. Then the second thing is the physical design, where you will basically create a chip able to create a project. Just I am running this program. This thing is here the section everything that were available in this CDAC module. That's how to connect with this. As I said, the trigger pin which will send you the ultrasonic wave and the echo pin will catch this wave. These two things were connect with this GPIO 0 and GPIO 1 and the wheel and ground for the power they have been connected. So just I will run this ultrasonic sensor. You can able to see the distance it has been calculated. When I closely to close this distance is 0. Like this, it will generate based on the wave that it has been sent and get using that it will calculate the distance that it will give you as an output. With this tool is called an Arduino IDE, where using this tool you can program it for the multiple processor like this Vega processor or Arduino kind of processor, and you can create your own IoT projects with this. This is the overview of what we offer here. We were able to we were do internship based on this 3 days workshop on this with this three tools that I had mentioned. Okay, the first thing is this with the Vega processor, we will have some sets of sensors, and will show how the final IoT project, some two IoT projects that how we can make with this processor. The second thing is the microwatt processor, how we can build your processor, and inside this
Working with partners to develop a chip too, very shortly. Even Mr. Kalabodi from IIT Madras showing interest in open door technology. So,
Chip design,
Yeah.
has come up with some concepts.
Yes.
If somebody creates a new chip, change the chip design, which is completely giving them as a
yeah. Yeah. AI presentation also we did or okay. Yeah, we are also doing LLM model and all this the foundation AI and all this stuff as part of our the projects as well as enablement, training and other stuff.
So is the automation trying to develop some of the AI modules
Yeah.
for say for education institutions and industry people to use or
AI model that is actually a roadmap we have, but right now
something like
we are using the open source based model and implement solutions. One of them is chatbot, for the local purpose within the organization. We can have that kind of a chatbot. We are working on it, and also we are recommending to some customers to some of the options, whether they want to have any kind of the feature implemented using AI. That also we do. And also we have customers from US who are actually taking some services from us. We do have US clients. So multiple. I mean, chip design is one of the pillar. The other one is actually the AI, where AI-based solution, cybersecurity, data related stuff, data engineering, all those stuff we do. And this is actually like, our core partners, IBM, Open Core Foundation. That's IBM's one of the foundation, and I'm actually spearheading that right now as a president for 190 countries. And CDAC, local government also working with us on various things. Did we show the CDAC, the Vega board demo? So you have seen that, right? The Vega board also as part of our thing. So this is actually made in India. Yeah, the board, whatever. Yeah. The CDAC about all this LLM and all this stuff to the people with the machine learning a little bit, deep learning a little bit, and then we'll talk about the IoT kits like Vega board. CDAC is supporting that. Even CDAC person probably will come there. Like I requested already to give a demo and probably expand that also. And definitely the chip design, the open power stuff, like where we will show.
That's really fun. We might have to test it out before we.
Yeah. Yeah, we did it with the PSPB students, and they understood that. It's not that we are doing good. Like here they did more locally.
Maybe we can check out.
Yeah.
You have clients in Chennai and Bangalore. You have any client, major client in Chennai? Client.
Yeah, we have a lot of clients, everywhere, like commercial. HCL is our client. HCL was working with us. Even HCL person was there, somehow, he left without, I didn't know that, I wanted to meet him. I wanted to talk to him further on some of the things. So anyway, he's coming back. HCL is our client. Like there, we have some of the clients, come and go, but some of the clients work with us. And many universities we are working with across India. In Gujarat, we collaborate with Nirma, we collaborate with GSV, a transportation-based university. And then, like I can name everything because we have been working with them. And Haryana also we have client. Punjab, IIT Ropar, we are working with them on a proposal. And IIT Roorkee, everywhere, like in the north, I'm telling because right now it's not easy to go there, but we are doing that. Not to the south. South we have all the states, where we have collaborations. Yeah, day before yesterday I was in Gandhigram University in Dindigul. I never knew that there are very good mathematicians there, and they want to develop a chip. They already agreed. VC was with me, for some time, to work on that. And Shastra universities are client. They bought a lot of our servers, open port servers, all the stuff.
Finding of right people. Finding of right people and universities.
Yeah.
Somebody.
Yeah, we have two pillars, right? One is enablement, and the other one is, working with customers, to do a project and research things, all the stuff.
So you may have research teams and create
Yeah.
those things and
Yeah.
team to focus on what you are.
Yeah.
I enjoyed one of your I enjoyed one of your new created videos.
I see a lot of people. No, I can't hear you.
Gautami.
Okay.
I'm from SRM Nagapura, BSc Commerce Science.
Oh, really? BS? What is it?
BSc Commerce Science.
Oh, okay. Oh, yeah, we work with Dileepan, Professor Dileepan from his group, right?
They are internship students, they are not internship.
Yeah. Yeah, welcome. Okay.
Myself Sridhanya. I studied in Chettinad Keshav and I completed my 12th grade.
Oh, okay. That's what I was
Thank you.
saying. Okay, sure. Welcome.
Thank you.
Yeah, welcome. Yeah.
We going to undergrad.
No, she's.
Joining college.
Yeah.
Yeah, that's what undergrad.
Graduate the results.
College is undergrad. Yeah.
I am Dr. Sri Sharmila, Associate Professor of Computer Science and Engineering at CEG Campus, Anna University.
Thank you, madam. Thanks for coming over here. Thanks for giving us an opportunity to host a program. And
It's our pleasure and
Yeah,
we
we'll
will
see.
do a lot.
Yeah, we'll see how we can collaborate more.
Yeah, sure.
Myself, Suranya. I'm coming from SRM Nagapura. Studying in BS.
Okay, thank you.
Mr. Prermila, I am from SRM PhD. Please.
Well, I'm Chuck from San Francisco Bay. I'm just here to.
Yeah, she has been supporting us, in San Jose area.
Well, I've been working few of those.
Sure. Thank you. No, Mother already. Yeah. JK, yeah.
42 plus years of experience.
Yeah.
Currently, I'm working as a consultant.
Yeah, JK is one of the chip design expert. We also mentored some of our team members, and we have been collaborating with you a lot. Thank you, JK.
Thank you. Hi, I'm Malik. So I'm part of Ideal Research around 20 years. I am more cultivate basically. Then Ideal is a solution architect. I came to India on vacation just now.
Thank you
Trying to go back.
for joining us. And let's see whether we can collaborate or so on the platform what you want to contribute. For sure. Thank you.
Good evening all, this is Thirumaran. I'm getting a HR consultancy from Nora PE do consultancy for both about studies as well as for job interviews.
Thank you very much.
Yes, sir. I'm Yogesh Kaur from SRM Nagapura campus, and I am here for internship. I have seen you before.